Okay, we have lesson 6, sum and difference identities. So the first part of this lesson is an investigation, just showing that these identities work. We're going to skip that. You can always plug some things into your calculator. So for this one, if you typed in sine of 60 plus 30 degrees, you'd find it equaled 1, whereas if you typed in all those things separately, you'd find it also equals 1. So that's just what the first page is. So here it lists the sum and difference identities. They're called sum and difference identities because one is showing the sum of angles, one is showing the difference of angles. Notice the equations are all quite similar. Some have plus signs, some have minus signs. So make sure you read these closely on your formula sheet when you have to use it. So the proofs of these are available. They're not the easiest of proofs, which is why they are just on our they're just on the formula sheet. We don't need to actually prove them or where it came from. We could develop the tan one by dividing the sine one by the cosine one, making some common denominators and working it out, but we're just going to skip to the examples. So again, these tangent ones are on our formula sheet as well. So example 1, express 15 degrees as a difference of two special angles and hence determine the exact value of sine of 15 with the rational denominator. So the special angles are always the ones on our unit circle, so like 0, 30, 45, 60, 90, and usually we end up using the 30, 45, and 60. So the reason we use those is because we know how to express those in exact values. So then we can express some more angles in exact values using those. So one way of writing 15 is 45 minus 30. You could also have gone 60 minus 45. There's multiple ways of doing these. So now I can use the sum identity for sine to say that the sine of 15 degrees is the same as the sine of 45 degrees subtract 30 degrees. And now I'm going to go to the sum difference identity and substitute in. So sum difference says sine of A minus B is sine A cos B. So this is then sine 45 sine A times the cosine of B, subtract the cosine of A times the sine of B. So now I can just go and find these values on my unit circle. So sine of 45 degrees is root 2 over 2. These are all in quadrant 1, so they'll all be positive. Cos of 30 is root 3 over 2. Cos of 45 is root 2 over 2. And sine of 30 is, 1/2. So now we just need to simplify. Root 2 times root 3 is root 6. So this is root 6 over 2 minus root 2 over 2, which we can write as a single rational expression as root 6 minus root 2 over 2. Okay, example 3, express 5 pi over 12 as the sum of two special angles and hence show that the cotan of 5 pi over 12 is root 3 minus 1 over root 3 plus 1. So this is probably would be slightly easier if we changed 5 pi over 12 to degrees and then found this sum, but it's possible to do with radians. We can say 5 pi over 12 is equal to pi over 4 plus pi over 6. So if you'd make a common denominator, you'd find that that does equal to 5 pi over 12, or 1/4 plus 1/6 is 5/12. So when we're asked to find the reciprocal ratio, it's easiest to just start by finding just the tan ratio, and our very last step will take the reciprocal. So we're looking for the tan of 5 pi over 12, which is going to be the same as the tan of pi over 4 plus pi over 6. So now we're going to go to the sum identity for tan, which tells us tan A plus tan B all over 1 subtract tan A times tan B. Okay, so I'm just going to move over here. Now we're going to start finding those ratios. Tan of pi over 4 is 1. Tan of pi over 6 is root 3 over 3. Then we have 1 minus, this is 1 times root 3 over 3. So simplifying, I can make a common denominator here. Oops, I should have made this one. So you will see that the tan functions here are all have a rationalized denominator. If from your unit circle here you got 1 over root 3, you could work through this process in a similar way. Your answer will look slightly different at the end, but it would be equal to the same thing. So now I have 3 plus root 3 over 3 minus root 3 all over 3. Now those 3's would cancel out. Leaving me with this. And now remember that this is the tan ratio. I want the cotan ratio of 5 pi over 12, so I'm going to flip this. So this is equal to 3 minus root 3 over 3 plus root 3. Example 4, simplify the following. Sine 100 times cos 10 minus cos 100 times sine 10. Well, if you look through your formula sheet, you'll see that that looks just like the sine sum identity. So that means this is really equal to, the sine difference identity, because it has a subtraction sign. This is really equal to sine of 90 minus 10. Sine of 100 minus 10, which is equal to the sine of 90, which just equals 1. So same thing with cosine now. We have cos of 1/4 pi minus theta times cos of 1/4 pi plus theta, etc. We see if we look at our formula sheet, this looks like the cosine sum identity, where angle A is 1/4 pi minus theta, and angle B is 1/4 pi plus theta. Wow, that means those thetas cancel out, and we're just left with that this is the cosine of pi over 2, because 1/4 pi plus 1/4 pi is 1/2 pi, or pi over 2, and the cosine of pi over 2 is 0. Last example, cos A is 3/5, cos B is 5/13, where A is between 0 and pi over 2, and B is between 3 pi over 2 and 2 pi. Find the exact value of cos A plus cos B. So the first thing we can do here is we want to find cos A plus B. So we're going to draw both of these angles on here first. So it says angle A is between 0 and pi over 2, so it must be in quadrant 1. And the cosine was 3 over 5, so that means the adjacent side over the hypotenuse is 3 over 5. And then angle B is between 3 pi over 2 and 2 pi, so that's in quadrant 4, and it has a ratio of 5 over 13. So let me draw this a bit better. This side must be longer. This is 5 up to here, and this is 13. Now, when we come to the sum identity formula for cosine, we are going to need to know the sine ratio as well, because this is cos A cos B minus sine A sine B. So we do need to know the sine ratio. So we are going to have to calculate this hypotenuse. So that's just Pythagorean theorem. 3 squared plus 5 squared, 3 squared plus y squared equals 5 squared. So this side must be 4. Same thing on the bottom. Using 5 and 13, this side must be 12. So now I can work with each ratio. Cosine of A, it told me was 3 over 5. Cosine of B, it told me was 5 over 13. Sine of A, well, this is our angle A here, so it must be 4 over 5. Sine of B is, not over 5, 4 over 5. Sine of B is 12 over 13. And we should check our signs, because not everything's in quadrant 1 now. So here, This is in quadrant 4, so the sine of the angle will be negative. So this becomes, you just put it all in your calculator and you will get 63 over 65.